Hey guys, welcome again to Math 135. This is the last section of chapter 2. And I gotta tell you, when I saw variation, I was like, bro, what are you even doing here in polynomial and rational functions? Variation. But anyways, I think it's I guess it doesn't fit anywhere else, so they're putting it here. I will say though, I guess you could argue a variation has like form like this. Like y equals kx is like the basic one. So I guess you could say this is a polynomial in a way. I mean, this is a constant, this is an x, so it's like a linear function, which is also considered a polynomial. So it's kind of a stretch, but whatever. Anyway, that's it. So the good news to me is that I think variation is a pretty straightforward topic. We're going to talk about 3 different versions: direct, inverse, and then joint and combined. But once we get to joint and combined, you're going to see that actually they're all the same. All 3 are, well, not the same, but you can all approach them very similarly. Okay, in this video, we're going to talk about the first one, kind of general overview first, and then the first one, maybe the second one if there's time. Starting with the general overview. So when you approach a variation question, basically you have 3 steps to do, and this is going to apply to all types. First, you write out the equation, whatever format it comes in, right? Secondly, you solve for the constant of variation, and we usually label that one k for constant, if you're spelling at a 2nd grade level. Okay, number 3, third, use that k and plug it back into the original equation. So then now you have like the actual number. You're not going to plug in k anymore. You're going to plug in whatever number, if it's like a 3 or a 5 or 2 or a half, whatever. And then finally, use that updated equation to solve for the thing that you want to know that's missing. Okay, so that's going to pretty much apply every time. Let's talk about number 1, direct variation problems. So starting with, okay, you got y equals to kx. That's the standard form for direct variation. Again, k is the what do we call it again? The constant of variation. By the way, it's a constant because it doesn't change. It's not a variable. Once you figure it out, that's just what it always is. It's just that number. Okay, we read this as y varies directly as x. Sometimes I've heard it read as y varies directly with x. But I guess as is the more standard reading. Okay, know that you can also rewrite this equation. If you take this equation right here and you solve for k, how would you do that? You divide both sides by x, right? And so you get y over x is k. So just keep in mind, you can always resolve for k, which oftentimes you have to do because you want to know what k is, right? That's typically how these variation questions go. You're given different values for x and y, and you use that to figure out what your k is. Once you figure out your k is, you can plug it back into your original equation and then solve for the missing piece. Okay, so let's try question 1. Question 1 right here. So move it down here. Sorry, I got some of the part above it too. Just ignore that. Okay, so here actually it's a little small. Let me do that again. Okay, so here we are. So it says y varies directly as x. So first step, we're going to just write the equation for this sentence right here. Y varies directly as x. That means y is equal to some constant of variation times x. Now, by the way, why do you say it varies directly? Well, because that means that as x increases, y also is going to increase. That's what it means to vary directly. Or I guess if k is negative, actually, you could say that opposite. If k is negative, then as x increases, y is gonna get more and more negative. But the numbers are gonna get larger, just more larger and negative. So that's kind of why the justification for directly. And if k is positive, then as x gets bigger, y is just gonna get bigger, right? Okay. So anyways, let's get back to it. What we're saying. So first thing we want to do is just figure out what our k is, right? And how do we do that? We take the values that are given to us, in this case 36 and 9, and just plug those in. So y is 9 when x is 36, right? So k times 36 equals 9. Yeah, okay. So then I want to find out, okay, what is my k then? What is k? Well, to do that, just divide both sides by 36, right? So k is equal to 9 divided by 36. And good news is both of those things are divisible by 9. Divide by 9, you get 1, divide 36 by 9, you get 4. 4, yeah. I don't know why it took me so long to divide 36 by 9, but okay. K is 1/4, okay? So K is 1/4. So now that I have my K, go into step number 2, which is rewrite my original equation, but instead of writing K, now that I know what K is, I'm going to change K for what I know K is, which is a 1/4. Okay, so I have my new equation. That was step 2. Last part is solve for what I'm missing. So now it's asking for what is y, right? They want to know what y is when x is -3. So plug in the part that you know. So 1/4, x is -3. So what is y going to be? And then you just plug and chug like my old middle school teacher, Mr. Corcoran, used to say. I think I told you guys about this. Okay, so you just plug it in. -3 times 1/4 is -3/4. And boom, you're done. Simple, right? That was a direct variation question. Okay, move on to indirect. Let's do direct and indirect. Maybe actually we'll even cover the last one in this first video because it's not. Nah, I think we'll just do the first two and then we'll cut it off. Okay, so now we're solving inverse variation problems. What makes it inverse? So in the direct, we saw that it was y equals to kx. In an inverse, it's y equals to k over x. Or an alternative form to write that exact same thing, you could write it as k times 1 over x. But they both are the same thing, right? If you just were to multiply this out, you have k over x. So it's the same thing, just two different formats. The reason why I gave this alternative notation is because you can kind of see the k off to the side, and the k is the constant of variation that's being multiplied. Okay, so we read this as y varies inversely as x instead of directly. This one was directly up there, right? So if the x is on the bottom, we say inversely. Okay, so now you write the thing in terms of k. Okay, so now if I was given this equation, right, and then I have a problem, typically what you want to do next is solve for k. So then you solve for k and you get yx. How does that come about? Well, looking at this original equation here, if I multiply both sides by x, those guys cancel out, and so you get xy or yx, right? Or it's not important. xy, yx means the same thing. Okay, so that's inverse proportions. Inverse variations in a nutshell. Let's try question 2. And then we'll cut this video off. In the next video, we'll talk about the combined. We'll do those. And then maybe in the last two, we'll do 2 more videos to end, just going over the word problems. Okay, so this one says P, so P instead of Y, is inversely proportional to W. That means it's equal to K over W, right? That's the interpretation of this first sentence, which may be the hardest part of this whole thing. Okay, and then it says when P is 2/3, P is 2/3 when W is 1/4. Okay, so here's a little tricky part. W is 1/4, but this is k over 1/4, right? So just a little reminder, what happens when you divide by a fraction? This is really k over 1 divided by 1/4, right? But what do you do when you divide fractions? You multiply by the reciprocal. So you flip it upside down and you multiply, right? So which is really just k times 4 over 1, but the over 1 is not necessary. So what ended up happening is you basically just flip this thing to the top, right? You flip the denominator. You flip this 4 up to the top and the 1 comes back down, which basically what happens when you divide by a fraction. Okay, so what does that mean? What do we end up with? We're going to end up with 2/3 is equal to just 4k. Easy, right? So now how do I solve for k? Divide by 4 on both sides. And what do you do when you divide a fraction by 4 or by any number? You just multiply it on the bottom, right? So it's 2 over 3 times 4 is equal to k. And that means k is equal to 2 over 12. And that can reduce to 1 over 6. Okay, so now I know k is 1 over 6, right? Let me erase this side scratch work here. I know k is 1 over 6. So now let me rewrite this thing. My original equation, right? P is equal to k over W. But k, I know, is 1 over 6. Okay, now what do you do when you have a fraction divided by a fraction? So this is like 1 over 6 divided by w, right? Which is like 1 over 6 times 1 over w. And so that's 1 over 6w, see? So then let me clean things up here. This 1 over 6 over w, that's just really 1 over 6w. That's what it really is. Okay, scratch work done. Okay, so now that I have this new equation here, this is my new starting point, right? Step 2 is done. And last step is just to plug and chug with the values that I'm given. So what are the values that I'm given? What is W when P is 3/5? Okay, so this time it's a little backwards, right? They're giving us the P. So just plug that guy in. That's 3/5 is equal to 1 over 6. And I'm trying to figure out what W is. So now from here, just solve for W. How do I do that? I'm going to multiply both sides of my equation by W. And also by 6, actually. No, I take that back. Not the 6, just the W first. Okay, so when I multiply both sides by W, what happens? Cancels on this side, right? So I have 3/5 W is equal to 1 over 6. Now, how do I get W by itself from here? Multiply both sides by 5/3. Over here, cancel, 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 cancel. Right? So I've got W equals to 5 over 6 times 2, which is 18. So there you go. That's it. That's it. Inverse proportions covered. All right. See you in the next video, guys.